Hey guys, this is Mrs. Vaught. I'm here today. This is the first recording that I've made for you. I really like the fact that you can't see me because I'm massive. I look like a big bowling ball is stuck in my stomach. So you get to hear my voice, you get to see everything that happens on the smartboard, but you don't actually get to see me. So when I lose the bowling ball and come back, then you'll actually be able to see me. So yesterday you should have t- filled out all your paperwork, got in the textbook, did all that sorts of fun stuff, and today we'll start talking about statistics. Hopefully, y'all did some sort of activity yesterday. I haven't planned that yet, so I don't know what you did yesterday. So today, the first thing I want to talk about is vocabulary. Vocabulary is one of the most important things you can really learn and understand in this class. This which seems strange about a math class. Statistics is not nearly as mathy as most of the other math classes you've taken, compared to, say, like pre-calculus, algebra. We don't do a lot of computational math in statistics. A lot of the numbers and the calculations we do, the calculator program runs for us. What statistics is really about is taking these numbers that you calculate and interpreting what they mean. So really being able to understand the vocabulary and the meaning behind all sorts of numbers, such as like mean and median, standard deviation. We'll talk about all sorts of things throughout the year. So the first vocabulary word let's look at is the definition of statistics, obviously. I really like this definition. It's very short and sweet, but especially because it has this word right here, science, in it. Now, whenever I decided I wanted to be a math teacher, I loved computational math. As a lot of you know, I'm teaching calculus this year. Was really excited about that. Um, Never a huge fan of statistics, actually, because it's very sciencey. There's not a lot of math that goes into this class. Y'all have been doing statistics if you've been taking AP Science classes all throughout those. But now we're really getting down into the mathematics of it, and we're really going to delve a lot deeper than you would in, say, like AP Bio or AP Environmental Science. AP Psychology does a lot of statistics. So it's a lot more like a science class. And we're going to take data, we're going to interpret it, collect, organize. So a lot of what statistics is data analysis, which is what I was getting at. Organizing, displaying, summarize, and asking questions about data. This asking questions is one of the most important things that we'll do. This is pretty much our entire second semester will deal with inference, where we actually ask a question about data, run some statistical tests, and see if we can get an answer. And this is what you have done in your science classes for any time you've dealt with statistics. Organizing, displaying, and summarizing is going to be a lot of what we do first semester, even over the next 6-8 weeks. We'll talk about mean, median, and mode. That's a way of summarizing your data, displaying graphs, charts, all sorts of things. Okay, so these two definitions right here, individuals and variables, will be really important later on. We'll actually do some questions and make sure you all understand. You can take a set of data, tell who is the individual and what is the variable. So the individual in a set of data is going to be who you actually collected the data from, the specific people. So if I take 50 random Central students and I ask them what their favorite TV show is, my individual would be those 50 Central students that I asked the question of. So let's say this right here. It is the people I ask the question. That's kind of a layman's term. I'll try to give you on these handouts the proper definition, and then I'll try to actually give you like a layman's definition that'll kind of help you remember or see what's going on. I asked the question of, let's put a preposition at the end. Yeah. You'll see throughout the year that my grammar and spelling is pretty atrocious. I'm a math teacher, so I always kind of push it off on that. Oh, I put this in the wrong spot. Let's see if we can move it. There we go. And move the of. That's better. Sorry. Alright, so variable is going to be like what you collect data about. It's the characteristic of an individual in which data can be collected. So if I'm looking at this same example where I asked 50 random Central students what their favorite TV show is, then the TV show would be your variable. Because you could say, I don't know, American Idol, all those other TV shows that are on. I don't watch TV, I wouldn't know. But a variable, this also says a variable can take different values for different individuals. So some of you might say a reality TV show, some of you might say like drama, comedy, whatever it is you like. So this is going to be, yeah, let's try this. The data is collected. That's going to tell you what your variable is. Now, if you think about, we have two drastically different types of variables that we can have. We have, oh, here we go. They updated the smart software, if you notice, that all this stuff at the top looks different than it did last year, and it's still getting used to it. Okay, so we have two different kinds of variables here. So think about if I asked you what your favorite TV show is. You would give me a word. You would say whatever it is, you know. If I asked you, how tall are you? You would give me a number. And I could take all these numbers, asked all of you in the class how tall you were, and I could find an average height. I couldn't find an average TV show. So these are two drastically different types of data. One is what we call a categorical variable, and it's just going to take your what you give them. So it's going to take you and place you into one of several groups or categories. Now, I could say, if I asked you what kind of TV show you like, I could say reality, drama, or comedy. And that could be different categories. Or I could just ask you specifically, what is your favorite TV show? And you could all give me the name of a TV show. And maybe you would all be put into different categories. Either way, this is a categorical variable. I generally try to remember to call it categorical because, oh, and I screwed this up too. Will you all correct this for me on your sheet? Actually, I'll probably go through and correct it before I make copies. But this should say qualitative. So hopefully on your sheet it says qualitative. Because it describes a quality. Now, if the answer that you give me when I ask you this question, whatever data it is I'm collecting, is a number, then we call this a quantitative variable. So quantity, obviously a number. And one of the most important things is to think about if it makes sense to find an average. Does it make sense here? There's a really neat example, I didn't put it on here, of someone gave it to me, and it was a question where they had taken the entire school and asked them to list their race. It was like 1 was Asian, 2 was Caucasian, 3 was African American, 4 was other. Say like that. So everybody goes through and they mark 1, 2, 3, 4 for their race. And then they go through and they find out that they take the average of all these numbers and they find out that the average is, say, 2.8. So does this mean that the average student is somewhere, between Caucasian and African American? That doesn't make any sense. Because what you're doing is, although you're assigning a number, you're assigning a number to different qualities or categories. So that would not be quantitative data, because you can't find an average. It doesn't make sense to find an average. So this is really important that you always think about this, because this, funny enough, when we get on to inference second semester, this is going to be a question that we ask ourselves a lot. Is our data quantitative or is it categorical? So you really need to be able to understand the difference between the two. So let's take a look at our first example. So y'all have this on your sheet. So read over it real quick. I'm going to pause this, and y'all can pause it, and then we'll get back together and we'll talk about it. So it's really helpful. When I tell you to read something in class, I expect you to read it. I don't expect you to be sitting out there reading a textbook, doing your AP psychology homework, or anything else. I expect for you to be doing what it is I'm asking you to do, especially since I'm not here, because you're going to take an exam over this before I get back from my leave. And if you can't pass this exam because you're not paying attention in class, then I would say that's your own problem. All right, so let's take a look at this. So we took took a census of students in Canada, Australia, New Zealand, South Africa, and the UK. And this is kind of interesting. And we took a bunch of different data about them. That didn't sound right. Took a bunch of data about these students. So we took gender, languages spoken, whether right or left-handed, height, wrist, communication, and travel time to school. So over here, the first question that they asked me is, who are the individuals in this data set? So we have to figure out who it is we actually ask the questions to. Not the big group, but more specifically than that. So let's go back. So we collect data about primary and secondary schools using a survey. So the hundreds, more specifically, hundreds of thousands of primary and secondary students from these countries who took the survey. Those would be our individuals. Oh, oops. And more specifically than that, this is important. We didn't go all the way through. So we use the site's random data selector to choose 10 Canadian students who completed the survey. So this is our individual. Because they did take hundreds of thousands of students, but I don't want to look at 100,000 pieces of data. That's not fun. We don't have enough room. My smartboard's not big enough. So we were only given 10 pieces of data, so these 10 students are my individuals. So they asked me next, what variables were measured? Identify each as categorical or quantitative. And then in what units were the quantitative variables measured? I'm not as particular. If y'all taking calculus, they're real ticky about y'all putting units, especially if they ask for them. In statistics, you're not going to miss a point on an AP question if you don't put the units on, but it's always helpful to think about it and make sure you're getting the correct units. All right, so let's go back. All right, so let's go through and figure out whether these are quantitative or categorical and what kind of units. So gender, Obviously, that's a word. We couldn't find average gender. That wouldn't really make any sense. I guess you could be half male and half female. We're not going to go there, though. So it's quantitative. The number of languages spoken. This is just, you could find the average number of languages spoken by students in Australia, Canada, New Zealand, and South Africa. So I think that average would make sense. Crap, I did this backwards again. Let's try this again. This is qualitative or categorical, so we need to put a C there. See, if I were here, you'd be able to correct me, but I'm not here. Alright, so then we say we can find the average number of languages spoken, so this is quantitative, and this is just a count. It's not a, there's not really any units on it, so it's just a number. Right or left-handed, that's obviously a word. Can't find average-handedness, so this is going to be categorical. The height, definitely a number. We talked about this earlier. You can find average height, so this is quantitative, and I'm just going to circle it. Right there's your units. It's going to be in centimeters. Wrist circumference is also quantitative. You can find the average. Right there is my units. Preferred communication. There's no numbers here. This is all putting into categories. So this is definitely categorical. And then travel time to school, this is all numbers. You could find the average travel time to school. Even gives you the units, so this is going to be quantitative. Okay, so then they say describe the individual in the highlighted row. So I don't really want to go all the way through this, but if you'll notice, they have just written a sentence or a few sentences about this student that is described in the highlighted row. So read over that. See how it's described. Here's your highlighted row down here. Ontario, male, so-and-so. As long as the copy worked out, you can see which one it is. There we go. And that's pretty simple. So what I want y'all to do now, I want you to try one of these on your own. So I've given you an example down here. Oh. And work this out. You can discuss it with the classmates around you. Don't take more than about 3 minutes. Shouldn't take you that long. So pause this, and then we'll talk about the answer. Okay, so here's the question over here. Same, very similar question to what you had over there. So it says that we are looking at a bunch of new roller coasters. And we took some data on several roller coasters that were opened in 2009. And the first question is, what are the individuals? So the roller coaster chosen to collect data on, just these 5 specific, oh, oops, try that's more helpful. These 5 specific ones are your individuals. Yeah, you could see what I mean. Part B says type and then categorical or quantitative, and then it asks for the units. I see their units written up here, so I'll go through and write them. So the type of roller coaster is going to be categorical. Steel or wood, you have 1 or 2 options. The height's going to be quantitative. That's going to be measured in feet. Speed is quantitative. Oh, design, sit down or flying, is going to be categorical. I wonder what about the ones where you like strap yourself in and your feet dangle? Maybe that's sit down. I think flying would be like where you lay on your belly, you know, stick your arms out in front of you. Anyway. So design's going to be categorical. Speed, which is in miles per hour. It's going to be quantitative. Duration, the amount of time, is going to be in seconds. And then I here, you can read this. Just wrote a sentence about the highlighted one down here, about the prowler. Read over that, see what you think. If you need more time, pause the video. You can write it down or correct anything. So today what we're going to be focusing on, we've done a bunch of vocab, learned about individuals' variables, the two different types of variables. So what we're really going to focus on is quantitative variables. There's not a whole lot that we can do with quantitative variables, so we're really just going to take one day. You know, if we can't find averages and we can't really run any numbers on them, it'll be helpful later when we talk about proportions. You could talk about the proportion of students who prefer American Idol as their favorite TV show, or the proportion of students who prefer reality TV shows as their favorite TV show. But we're not really going to get into that right now. We're all going to talk about how to graph categorical data, and then we're going to talk about what's called marginal and conditional distributions. So this is all baby work. My second grade son last year did pie charts and bar graphs. It's pretty obvious. A few helpful things you should remember about pie charts and bar graphs. The first one about a pie chart is all the percents must add up to 100. The pie represents the whole, the entire, all of it. So they have to add up to 100. And then you would just take, and each section of your pie would represent that percent of the circle. Now, if I ask you on an exam or somewhere to make me a pie chart, I'm not going to expect for you to take a protractor, get it out, take your percent, make a ratio out of 360 degrees, and make it exact to the degree. That's just too much work. We don't care that much. But I do expect for it to be accurate, as accurate as you can do by hand, which means if you have one pie slice that's 25% and one that's 35%, the 35% pie slice needs to be bigger. I will take and make sure that it's fairly accurate. Now, it may take you a few tries to draw a good one, but it's okay. It takes a little practice. Bar graphs. Bar graphs, I think that's almost too easy to mention. Bar graphs can do, I will mention this, they can represent percents of the whole, or they can represent counts. So if I found out that of my 50 Central students, 20 of them prefer reality TV shows, 17% prefer dramas, and 30 prefer reality, 17 prefer drama, 13 prefer comedy. Then I could take and make a bar graph. One bar could have a height of 20, one of 17, one of 13, so on. Or I could take and I can make percents and say, okay, 30 out of 50 is this percent, 60%, and make a bar that height, and so on down the line. One thing that's really important with all types of graphs is that you label correctly. So let's say this in red over here. Make sure that you label correctly. So if you use percents as the height of your bars, you tell me that it's a percent. If you tell me it's just the number of students who prefer these types of TV shows, you tell me that. Always have to make sure you label correctly, and you always make sure that you put a title on every graph. I'll count off points. You'll realize this later when you get your Unit 1 test back and you have a point taken off on every one of those graphs because you didn't put a title on it. I need to be able to look at your graph and understand exactly what's going on, even if I haven't read the question. So, we're given some data here. We have, let's see, 1, 2, 3, 4, 5 different age groups. And it says the percent of these age groups that own an MP3 player. So 54% of 12 to 17-year-olds own an MP3 player. Wait, hold on one second. Okay, that's fine. So the first thing they ask us to do is to make a well-labeled bar graph to display the data. I'm not going to make a bar graph by hand because you have a nice picture right here, and I expect if my second grader can make a bar graph, then you also can make a bar graph. Okay, so here it says that 54% of 12 to 17-year-olds own an MP3 player, 30% of 18 to 24-year-olds, 25%, and so on. It's nice here that the bars go from highest to lowest. That's not always going to happen for you. Notice that they've labeled correctly. They haven't put a title, so let's put a title on it. So this is going to be, let's see. The title of the question is always helpful. So like this right here, a lot of times if I don't know what title to put on my graph, then I'll just insert the title of the question. Who owns an MP3 player? There's my title. Part B says, would it be appropriate to make a pie chart for these data? Why or why not? So y'all think about this for a second. Obviously, the answer's right there. You could read it, but it would be more helpful if you thought about it first. Okay, so hopefully you've thought about it. Let's see the best way to explain this. The percents that you're given for each category are not the percent. It's not saying that if we took all of the people in the group, like took all of MP3 player owners and divided them into ages, then this would be your percent. That's not at all what it's telling you here. It's telling you that 54% of 12 to 17-year-olds own an MP3 player. So the only actual decent pie chart you could make would be 4 separate pie charts, 5 actually, for each one of the different age groups. So for example, let's see if I can make a circle. That'd be kind of cool. Here's a circle right there. I could say, go back over here to my markers, okay. 54%, so watch how I do 54%. I know half would be all the way down, so I'm just going to do a little more than half. Yeah, it's not so bad. So here I could say the red right here represents owns an MP3 player. Let's actually, there we go. I'll make a little key down here. And then the blue represents those who don't own an MP3 player. So, owns an MP3 player. And then the blue would be does not own. And this is only for 12 to 17-year-olds. So the only decent pie chart we could make would be for all 5 separate categories. And this blue over here would represent If this has to represent the whole thing, then in order to get those who don't own an MP3 player, you would just subtract 54 from 100. So this over here would be 46%. And then this over here would be 54%. So it says here, making a pie chart to display the data is not appropriate because each of percent in the table refers to a different age group, not to parts of a single whole. Now, there are times whenever you want to check and make sure, they like to be tricky in their questions, that maybe they do give you, they take all the people that own an MP3 player and they divide them into different age groups. But they leave off the 55 and older. So say if this weren't here, and we were given, we took 100 MP3 owners and looked, asked them their ages. Let's see what the distribution of ages is. Then if all your percents don't add up to 100, you have a problem. You can't make a pie chart if your percents don't add up to 100. So it's sometimes helpful to add like an other category at the end. And so that would just be everything together added up minus 100. And that would be how you would calculate your other category. All right. So that's a qualitative graphs. Crap. Categorical graphs. So here are some bad graphs and good graphs. I try. It's a lot easier at the beginning of the year to look at actual things off the news and data. I'm generally better at the beginning of the year. I'll try a little harder to actually pull things that are meaningful into our lessons. So what I've done here is I found Fox News, and I'm sure all the other ones, but Fox News especially, it's really bad about showing really bad graphs. So here what they've done is they have this is what we actually call a time series graph. We don't really need to know a lot about time series graph, but it would be nice for you to be able to recognize them. It's what we call a line graph, which means it's a bunch of dots connected by lines, you see. And we call it time series because the x-axis is always going to be time. Now this is actually more quantitative data because we're looking at the total number of people that are unemployed. But it's really important here to look at the scales. Here is the exact same graph. On top, we have the scale that Fox News gave, which makes it look like the unemployment rate has been increasing the same amount from December of 2007 until June of 2010. But because what they have here is they have that they're claiming that this distance right here, let's do that in black, is 2 million, and then this distance right here, which is not much bigger, is 4.5 million. And then this distance right here, which is about the same as the bottom one, is 1.5 million. So obviously they're not getting their scale correct. So if we actually take and we put a correct Y scale on it, we see that it is a drastically different line graph. So it's really important. And it's important if you're watching the news to be able to recognize these things. They like to trick you. Obviously Fox News, y'all can interpret whatever agenda they're trying to push onto you with this graph here. I won't push my own agenda on you. Well, sometimes. Here are a few other bad graphs. These are some pie charts. Here is federal spending, two different graphs for federal spending in 2010. One of them, this is kind of going the other direction actually. One of them shows you all the different percents of what the government is spending their money on. I can tell you how accurate this stuff is. Sometimes I find things from news sites. I don't always trust news sites. But here, everything is well labeled. I don't as much like the fact that they're not giving you the percents here. You know, it would be better if they would actually list all of the percents for every category. Over here, though, they list no percents except this. And what is X? It's quite strange. What in the heck does that mean? So list no percents. They don't label one of their categories. They call it category X, which makes no sense at all. They give you no sort of key. They do tell you I guess they give you all of this down here. But this is what I would call a bad graph. This is what I would call a good graph. I think you actually have a homework question that asks you to interpret one or the other. One really bad way of drawing a bar graph is to not use the same size increments for your bars. So I think that sometimes they like to do, like, say that we have a bar graph here. If I could do this offhand. And say that we're trying to represent, you know, the number of apples sold and the number of oranges sold. So say that we have, and this is our orange, and one orange represents 1,000 oranges sold. And then here is our apple. I don't know if that looks like a good apple. I'll put a little stamp on it. And this represents 500 apples sold. So I could say, like, we sold 1,000 apples, right? That would represent 1,000 apples. Or here, this represents 1,000 oranges. Now that doesn't make any sense because they represent the same thing, but they have different heights. And your mind is kind of trained, because you've been doing bar graphs since 2nd grade, that the height of the bar represents the quantity, but these heights are not the same. So you would probably look at this and initially think that they sold the same, fewer oranges than apples. But obviously, if you look at the key, they didn't. So pay close attention. This is not a good way to make a bar graph. All right. So let's talk about what we call two-way tables. This is a really good way of representing quantitative data. Did it again all the time. I mix them up. Categorical data. Lesson today is on categorical data. It's a really good way of representing categorical data. So what we have is we have taken a set of data. We have looked at males and females. Taken one big group of people, 4,826 of them, and we've decided to see, oh, here, it tells you what it's about right there. If we asked 4,826 young adults, what do you think your chance of getting rich is? Some of you may have a very strong opinion on this. Some of you may not. I mean, I'm kind of pragmatic. I knew at the age of 14 that I was never going to be a rich person. The way it is. Some of y'all, you know, you have awesome expectations for yourself. You think that you're going to be rich one day. So they thought it would be interesting to compare males to females. So they've actually taken, and they took all the different people, asked them what their gender was. I guess if it was a piece of paper, you'd have to ask if it were, I don't know, whatever. Maybe they could just visually tell. And then they asked them what they thought their chance of getting rich was. We call this a two-way table because we actually have 2 columns or more and 2 or more rows. So I don't think I gave you the definition of a two-way table over here. Let's look. No, I didn't. So let's define it over here. So it's going to be a table of categorical data that has more than 2 rows. Let's say 2 or more, actually, because it could have just 2 rows. Sorry about that if you're writing. Two or more columns. And so what you've done here is you've taken a set of data where you could have just listed the young adults and their opinion on whether they're going to get rich. And you can make a really easy bar graph about their opinion. You know, each of those things on your x-axis would be the different categories. Almost no chance, some, but probably not, yada yada. But since we've taken and we've split them into male and female, that gives us 2 different categories here. Then we've made a two-way table. Now the totals are never going to count in terms of the number of columns. So, and I guess if you just had one thing here, it wouldn't make sense to put a total over there. Oh, oops. There we go. Okay, so let's talk about distributions. Oh. So, the distribution of a variable tells us what values the variable take and how often it takes these values. So if we go back here, if you look down here at this example that I've given you, all these examples deal with the data on the previous page. So you could have, honestly, you could have several different distributions about this set of data. So because we have several different variables, we have the gender variable. So we could take our 4,826 people and just have the variable of gender. You know, what percent or how many of them are female, that'd be this many, and how many of them are male. We could also take and we could look at the totals on the column over here, and we could look at the variable of their chance of getting rich. And this would be almost no chance, some chance, but probably not. And we could find the percent or the number just for that. And that would be a variable. We also have another way that we could do it. We could make a table that is just females and make a table that's just males. And look at the percents or the numbers just for females and just for males. So these actually make up 2 different types of distributions. Generally, let me make this note, a distribution is going to give you percents of the total. And generally, we could look down here at how they're doing it, but we'll talk about it in just a minute. All right, so the first type of distribution that we talked about, where we talked about just gender or just chance of getting rich, this is what we call a marginal distribution. And this is, I guess it's given the name, by visually, it's what is in the margins. It's going to be your totals. Sometimes you're not given totals. Sometimes you're just given the number of males and the number of females. So if you were asked to create a marginal distribution, they would ask you whether they wanted it to be for gender or for opinion. If you were asked to give a marginal distribution for opinion, you would actually have to add these 2 things together and get the totals. Fairly simple math. And then you would go through and take all the totals and make a percent out of them. So let's take a look at what they did over here. So let's read. The definition's kind of fancy. It's a little harder to read. For one of the categorical variables in, let's see if I can correct that, a two-way table of the counts is the distribution of values of that variable among all the individuals described in the table. So it's actually going to be a distribution in the margins, or the totals. So if we look down here, they calculated the marginal distribution of opinion. So what they did is they took the number who thought they had almost no chance of getting rich, some chance, 50-50 chance, or a good chance, or almost certain, and they divided them by the total of everybody, the 4,826. Another thing to remember about a marginal distribution is that you're always dividing by the total of everyone. Oops. All right, so a conditional distribution. This is one where you take and you say, okay, I want to make a distribution of opinion, but I want it to just be for females. So it's not going to be in the margin. It's going to be in one of the rows or columns. And so let's see if we can read this. I wrote on it, but hopefully you didn't write on yours. A conditional distribution of a variable describes the value of the variable among individuals who have a specific value of another variable. So in this case, for us, that would be like gender. So we could have a separate conditional distribution, for male and female. And the big thing about this is instead of you dividing by the total of everyone when you calculate your distribution, you're going to divide by the column or the row total. So if I wanted to make, let's see if we have an example on the other page of a conditional distribution. Oh, we don't. So let's go back over here and look at this. So a conditional distribution for opinions of females. What I would do is I would go through and say no chance, some, oh, oops. Try that again. $50-50, good, certain. And we looked over there at how to make a marginal distribution of this. We're going to look at everybody combined. But a conditional distribution for females is we're going to take the number of females who think that they have no chance and divide it by the total. Your total is 2367 for this one. So we take this and divide it by 2367. I'm not going to find the percent, so if y'all want to do that on your own calculator, that's fine. Some chance, but probably not. We would take the number of females, the 426, and divide it by the total of everyone. 67. If I could write, helpful. And then we're going to take the 50-50, the 696, and divide it by the 2367. And then we're going to take the good chance, the 663, and divide it by the 2367. And then the 486, and divide it by the 2367. And there is a conditional distribution for females, for the opinions of females. So the biggest difference, if you see right here, is what you're dividing by. And the fact that you're only looking at these numbers right here in the female column. Now you can see where like this whole table could be flip-flopped. And your columns could be opinions, and your gender could be rows. And so I'm not going to make it specific to columns or rows, because you can see it both ways. All right. Now you can take, I thought this was a good thing to show you right here. This is what's called a segmented bar graph. So what we've done is we've calculated the percent for male and female for each one of the opinions. And if you notice that the height of all these bars are the same because they're all 100%. Either they're male or they're female. So, and we've taken and made a segmented bar graph, and it kind of is able to show the difference, which is higher, which is lower, and so on. So here, in order to calculate the values for the almost none piece of our segmented bar graph, we would have taken the red as female. So we would have taken the number of females divided by the total and got a percent. That'd be the total of everybody. And then we would have taken the number of males, divided it by the total of everybody in that column. No, wait, I'm wrong again. Man, I really wish y'all were here to correct me. I wouldn't feel like an idiot. Okay, so let's go back and look over here actually just a second. So we wouldn't take it out of the total of everybody. We wouldn't be dividing by 4,826. What we'd be doing is we would take, for the female piece of that very first bar, would be 96 divided by the total of the almost no chance. So it'd be 96 over 194. For the male, it'd be 98 over 194. So let's go back and write that in so you can see it if you need it later. So this is going to be 96 over 194, and this is going to be 98 over 194. So you do that, and you would use the total for each row, the total for all the opinions. All right, so I have one more practice problem for y'all to do. So you need to pause the video, you can work with the people around you on this practice problem, and then we'll come back and look at the answer. Okay, so here's our practice problem. And they want us to create two different marginal distributions. The first one for whether the visitors rented, owned, or had never used a snowmobile. And the second one for those who belong to Environmental Club. So remember, your marginal distribution is just going to be what's in the margins. And here it's kind of helpful because they've given you the totals. So for part A, if we're going to look at the marginal distribution of those who've never used, rented, or owned, I just make those my different categories. And I look at the percent of everyone, because that's what's in the margin, is everyone, who have never used a snowmobile. And it's 657, right? This right here, of the total of everybody, the 1526. And I get 43.1%. Then I'm going to go through and I'm going to calculate the percent for snowmobile renter. And that's the 574 over 1526. And then I'm going to do the same thing for snowmobile owner. And that's the 295 over 1526. These will not always add up to 100, but they should be approximately 100%. And that it's not always going to be exactly 100 because of round off error. You know, when I round things, I always expect for you in this class to round correctly. I generally don't care how many decimal points you give me. In fact, I never care. I shouldn't say the word generally. But I do expect for you to round correctly. If you were to tell me that the percent of snowmobile renters was 37%, I would count points off because you're not rounding correctly. Now, if you told me this was 38%, that's fine with me. I don't care as long as you're rounding correctly. Okay, so this is my marginal distribution for their never used, rented, or owned snowmobiles. And now this part B says marginal distribution for those who belong to an environmental club. So look at the total of all the people I talked to. 305 of them belong to an environmental club. So I find the percent of the total that belong, and it actually ended up being almost exactly 20%. And then for part B, I find the percent of those who do not belong to an environmental club. So it's going to be the 221 out of 1526. So this is all I have for y'all today. So we talked about categorical variables and different ways to represent them. So we have gone through and we've talked about bar graphs and pie charts. That's one way to represent them, that's visually. And then we talked about bad graphs versus good graphs, making sure that we're using the correct scale on both our X and Y axes. And we are correctly labeling our pie charts. We saw that funny pie chart where it wasn't correctly labeled. And then marginal and conditional distributions. These distributions will come up later when we discuss probability. So it's good if you actually go through and get a good understanding of these types of two-way tables because you'll definitely use them later. All right, so you're going to get some homework from me. Anytime you're assigned homework, it is always due the following class period, unless I give you special instructions, which will very rarely never happen. So your homework is going to be due next class. It'll be collected. I'll take a look at it and grade it. When I come back, things will work a little differently, but at this point, I'm actually going to collect and check your homework each evening, and then we will discuss it the next class period. So make sure that you're doing things accurately, you're taking your time. I kind of pride myself in not giving you guys a whole lot of homework, but giving you quality homework. So I expect quality answers out of you. I'm not going to assign you 50 questions like maybe your pre-cal teacher did every night. I'm going to assign you somewhere between 6 and 8 questions. But I expect that you take your time and you do the questions correctly. All right, so you guys have a great evening, and I will